This is the last of our techniques of integration, and this one's going to be not as bad as some of the ones that we've done in the past with respect to like trigonometric integrals, integration by parts. Or let me rephrase that, not as tedious, because we are going to use some of those techniques. But an improper integral has some sort of discontinuity, all right, in it. And what we're going to do is we're going to go through and try to evaluate these. Some of them will be able to be evaluated, some of them won't, all right? So there's actually three different types of discontinuities we're going to look at, but just as an example of what an improper integral kind of looks like. All right, so we have a function 1 over 3 minus or square root 1 over the square root of 3 minus x from 0 to 3, and we certainly know that this function we can't plug 3 in. But if we were to go through and try to graph it, it looks like this area is eventually going to kind of squeeze off. Like if I was, in other words, it looks like it's asymptotic and it's kind of merging towards 3. So what we're going to do is instead of trying to go and evaluate at that endpoint, we're going to take the limit as the value approaches that endpoint. Okay. And by the way, if we were to use a computer algebra system, then this would be the value that we get for this. Okay, so it's convergent. So any sort of time that we have an improper integral or any integral that gives us a specific value of a real number, it's convergent. However, if it doesn't go to a real number, or if it's infinite or if it's imaginary, then it's divergent. Okay, so if I say those terms throughout these video series with respect to improper integrals, that means that just it either has a real number value or doesn't. Okay, so in this video, all we're going to do is we're going to look at the various types of discontinuities, and we're going to try to evaluate integrals. So 3 types, one of which is an infinite discontinuity. Okay, so it approaches the value approaches either negative infinity or positive infinity or 1 to bounds. Okay, like we saw before, there might be a discontinuity at one of the endpoints. All right, so we either have an infinite discontinuity, an endpoint discontinuity, and then sometimes we have a discontinuity somewhere in between here. All right, so if that happens, then what we're going to have to do is we're going to have to break up the integral, okay, into 2 separate integrals and evaluate. All right, so we'll see a lot of these as we go along. Okay, all right. Let's take a look at a really basic example. In fact, it's probably the one that's really close to the first thing that we saw. So we have integral from 2 to 5 dx over square root of x minus 2. Now, what we do is we first of all look for a discontinuity. And in this case, it looks like at x equals 2, it's not continuous, or the integral's not. So what I'm going to do is I'm going to take the limit as c approaches 2 of the integral from c to 5, not 2, but from c to 5 of dx over the square root of x minus 2. And to evaluate this, it's a u substitution. I'm going to let u equal x minus 2. du is dx. And it's perfect. That's exactly what we want. So when we evaluate this, this is going to be the limit as c approaches 2. Integral. Now I'm going to say from c to a because we're changing bases. We're going to be in terms of u. So this is going to be du over the square root of u, okay, which is the same as the limit as c approaches 2 of the integral from c to a of u to the minus 1/2 du. And now we're going to evaluate the integral. We're just going to add 1, divide by the new exponent. Okay, so we still have our limit as c approaches 2. We're going to have u to the 1/2 divided by 1/2 from c to a. We're going to back substitute. So now we get lim as c approaches 2 roots. Okay, so that we just take the reciprocal of the half. The 1/2 power is the square root. Remember, we had x minus 2, right? And this is going to range from c to 5. We're going to substitute 5 in immediately. We're going to substitute c in, but take the limit. So we're going to get 2 square roots of 5 minus 2 minus the limit as c approaches 2 of 2 roots of c minus 2. This one just works into 2 roots of 3. That's pretty easy. So this is going to be 2 square roots of 3. And then if I directly substitute 2 back in, because now it's within the domain, we have 2 roots of 2 minus 2, which is just 0. And so ultimately, our answer is going to be 2 roots of 3 for this. Okay. Of course, we want to use something like Wolfram Alpha to maybe check our answer to at least make sure we're on the right track with this. All right. And just to show you what would happen if you were to use Wolfram Alpha with this, I'm going to go in here. I'm going to say this is 1 over the square root. I just used the example from the beginning. So this is x minus 2, and we had x ranged from 2 to 5. So if I execute this, all right, we get 2 roots of 3, okay, which was precisely the answer that we got before right here. So one of 2 things happened. Either I pulled some sort of magic to make you think this works, or it actually does work. Okay, so go with the latter on this. All right. For the rest of this section, we're just going to take a look at all the different types of improper integrals and some various examples of this.